Assalamualaikum warahmatullahi wabarakatuh. My name is Alfitra Primaputra, and in this video, I'll be explaining to you about FM stereo. First of all, what does FM stand for? FM stands for frequency modulation, which means that a signal is being modulated by adjusting its frequency for transmission. Now, FM systems have low noise effects, which allows it to transmit high fidelity or high quality audio. And the transmission technique used in FM system is the FM stereo transmission technique. Now, in FM system, we have two different audio inputs, which is the L and the R inputs. And this input of L and R signals are being transmitted simultaneously to achieve a higher quality audio. So in this FM stereo presentation, we will be focusing more on the FM stereo transmission technique. The FM stereo transmission technique has three main parts: the generator, the transmitter, and the receiver. And before we get into each of the parts, we have to know about the FM stereo multiplex signal, which has three signal components: the L plus R mono audio, the 19 kilohertz stereo pilot, and the L minus R suppressed carrier or different signal. So another word for the L plus R signal is the sum signal, and we have the stereo pilot over here, and then we have the different signal over here. Pay attention to the frequency of each of the signal components, as we will be discussing about it later in the video. Moving on. So an FM system uses frequency division multiplexing to combine two signals designed for left and right hand loudspeakers. The signals are first passed through filters, which only allows frequency up to 15 kilohertz. So we have two components of signal, the left and the right signals, to be transmitted simultaneously. And the signals are first put through a filter that allows it to reach up to 15 kilohertz only. And the starting baseline is 30 hertz. The L and R signals are then passed through a mixer to produce a sum signal or an L plus R signal over here, and subtracted one from the other to produce a different signal over here. The sum is the monophonic component of the signal, and the different signal is used to modulate a 38 kilohertz sine wave using DSBSC modulation. The DSBSC output is then added to the sum mono signal or the L plus R signal over here, and the combination is sent on the transmitter FM's modulator. A 19 kilohertz master oscillator, 19 kilohertz pilot, at the transmitter acts as a pilot tone to which the 38 kilohertz subcarrier oscillator is phase locked. Phase lock meaning that the 38 kilohertz will have the same phase as the 19 kilohertz pilot tone, but it can have varying frequency as long as it's the multiplication of 19. The 19 kilohertz pilot tone falls in a spectral region above the L plus R signal and below the L minus R signal. As you can see over here, the 19 kilohertz pilot tone is just right in between the L plus R or the mono audio and the L minus R signals over here. The DSBSC signal extends 15 plus minus kilohertz around 38 kilohertz since the input modulating signals are band limited to 15 kilohertz. So to recap the generator part of the FM stereo, we have two different inputs, left and right. Each input is then put in a mixer and a filter to limit it to 15 kilohertz. We have the L plus, from that we have the L plus R signals and the L minus R signal. Now the L minus R signal is combined with the 38 kilohertz subcarrier signal. And then we have the pilot tone over here. After we add the different signal and the 38 kilohertz signal, We then mix it up with the L plus R signal or the sum signal, and then we then put it through a mixer with the 19 kilohertz pilot tone before then transmitting the end product of the signal. Moving on, we have the FM stereo receiver. Oh, before we move on to the FM stereo receiver, what I mean by the DSBSC signal extending 15 kilohertz above and below 38 kilohertz is this. Because the limit of the signal is 15 kilohertz. So from the starting point of 38 kilohertz, we go 15 below and 15 above. So this acts as a suppressed carrier signal or the different signal. So moving on to the FM stereo receiver. FM receiver is used to produce the original R and R signals. The transmitted FM signals passes through a discriminator. This is a discriminator, which eliminates the carrier signal. Now, the sum, the difference, and the pilot carrier signal will be separated using LPF, and 2 BPF, respectively. So the sum signal or the L plus R signal will go through an LPF filter or a low-pass filter, whilst the other two goes to a band-pass filter. The stereo receiver looks incoming FM modulated signal. It knows that the 15 to 23 kilohertz range should be vacant unless a stereo signal is being transmitted. A 19 kilohertz pilot tone is present. If a 19 kilohertz pilot tone is present, it can be recognized and used to control the frequency and phase of a 38 kilohertz oscillator. So if this is present in between 15 kilohertz and 23 kilohertz, the suppressed carrier can be controlled by the stereo pilot or the pilot tone. This can be demodulated, the difference information, and combine it with the mono sum signal to recover original L and R signals. So after the signals goes through their respective filters, so the L plus R signal goes to the LPF straight to the decoder. The different signal goes to the L minus R signal goes to a mixer to be mixed with the carrier signal or the pilot tone signal, which is then doubled to 38. Just like before, it goes through the encoder, mixed with the L minus R signal, and then goes through another LPF or another low pass filter to go to the decoder. Now in the decoder, the signals will be added and subtracted to get the original L plus R signal, like the input before going through the encoder or the generator over here. Moving on, the FM stereo has a specific stereo frequency spectrum. Now, commercially, the FM stereo frequency spectrum goes from 88 megahertz up to 108 megahertz, containing more or less 100 channel, maximum 100 channel. So if we look through each channel's frequency spectrum, for example, we have channel 1 over here at 88.1 megahertz and channel 2 at 88.3 megahertz. Each channel extends 200 kilohertz, has 200 kilohertz as bandwidth, and then each channel is guarded by a 50 kilohertz guard band so that it won't overlap. The 50 kilohertz guard band is made out of two 25 kilohertz guard band. So this guard band is in order to protect each channel's sound quality, basically. If a channel 1's bandwidth extends from 200 kilohertz, it will penetrate the 25 kilohertz guard band over at channel 2, and it will cause some interference to channel 2. So ideally, the maximum frequency deviation of FM stereo channel is 150 kilohertz or 75 kilohertz below and above the midpoint of the channel.